Hello everyone, good evening, welcome to Dr. Ravi's Academy. In today's class, you will be learning one very important concept of engineering mechanics, that is moment of a force and Varignon's theorem. So let us understand the definition of a moment of a force. Let us look at here. I have taken a spanner, double-end spanner, and this is my rigid body, and you have a hexagonal bolt, and you want to open it up. So in order to open that, you have to turn it anticlockwise. So you have to apply the force P in order to rotate anticlockwise so that it gets opened. So you are providing a turning effect, a rotational effect by means of a force, and which is known as the moment of a force. So the qualitative meaning of it is it produces a turning effect, a rotational effect on the body, on the rigid body, is called moment of a force. And let us look at another force, Q. The line of action of the force is Q, and if you want to tighten the bolt, then you have to apply clockwise. So observe carefully, P is producing anticlockwise moment and Q is producing clockwise moment. That means you have two types of moments. Usually anticlockwise moments are treated as positive moments, and clockwise are treated as negative moments. So you can write down the expression for moment of a force. Let us write down here moment of force P about O is the magnitude of the force multiplied by the perpendicular distance, that is shortest distance between the line of action of the force and the moment center. Your O is moment center, it is moment center, and D is moment arm, it is known as moment arm. And the same way you can write down the expression for moment of force Q also about O, it is Q into D. So that means this is anticlockwise moment, here it is clockwise moment. That means you have two types of moments. So these are the magnitudes of the moment of a force. It is the magnitude of the force, moment of a force P about O is the magnitude of the force P, and D is the moment arm, shortest distance between the line of action of the force and the moment center. And this is the concept of moment of a force. You have anticlockwise and clockwise, you have two types of moments. Now let us look at Varignon's theorem. The Varignon's theorem is also known as principle of moments. The Varignon's theorem it is also known as principle of moments. So let us prove this, state and prove this. I am writing mathematical equation. The moment of principle or Varignon theorem states that moment of a resultant force about a point O is the algebraic sum of moments of its component forces about the same center. It is algebraic sum of moments of its component forces about the same center. Let us see that P and Q are the component forces and R is the resultant force. So this is the mathematical statement of Varignon's equation. Moment of a resultant force about a point O is the algebraic sum of moments of its component forces about the same center, that is O. So let us prove this. For that, let us consider two forces P and Q and the resultant. Now I am considering a force P at certain angle theta 1 with respect to the horizontal line, and another force Q, and let us form a parallelogram, and this is the resultant R. Let us attach the coordinate system, and this is point of concurrency. Let us attach x and y, right, and let us see that this is your force P and Q, R is the resultant. Let us assume that your P is inclined at an angle theta 1 with x axis, right? You want to write down moment of forces about a point B which is on the y axis. So, to write the moment of this, you have to erect the perpendiculars. So, let us erect a perpendicular to, this is perpendicular. So, this distance I am calling it as D1. So, this is making the same angle theta 1. Similarly, you want to write moment of the resultant force, erect a perpendicular to R, and this distance you call it as D, and this angle call it as theta, and this is also theta. And lastly, extend this and erect a perpendicular to it, this you call it as D2, and this angle, let us say this angle is theta 2, and this total angle is theta 2. The figure is very simple. You have considered P and Q, two component forces and resultant, and the angles with respect to x, you have measured that theta is the angle made by component force P, theta 1 is component force P, and theta 2 is component force Q, and theta is the resultant force R. Similarly, from geometry you are going to obtain the same angles as you have erected the perpendiculars. It is D1, D and D2. So, this is your D1, right. Now, from the figure, let us write down the expression for moment of the component force P. The expression for moment of, I am writing it as moment of force P about B, point B, is equals to, as you know that the force multiplied by the perpendicular distance D1, and from this triangle, observe carefully, from this triangle, right triangle, your D1 will be OB cos theta 1. So, that you are replacing, it is P into OB, it is cos theta 1, right, and this you can write down, it is a moment of P about B is equals to OB times, it is P cos theta 1. Let us see that P cos theta 1 is the x component, you can call it as Px, and this is Px, call this is equation 1. Similarly, you write down the moment of force Q about the same moment center, that is B, moment of Q with respect to B. So, moment of force Q, this is the force and this is the distance. So, that is your force Q into the momentum, that is D2. From this right triangle, D2 you can replace that OB cos theta 2. So, this you can write down Q into OB cos theta 2, and in turn you can write down moment of force P about B, moment of force Q about B is it is OB times Q cos theta 2. Here this is what is your Q force, and this component, this is Qx, Q cos theta 2 is Qx, you can write down it is Qx, this is equation 2. And lastly, the third equation, moment of the resultant force, it is the moment of the resultant force R about the same point B is equals to, it is R into, here the distance is D, momentum is D, and D you can replace from this right triangle, D you can replace OB cos theta. So, you can write down that R into OB cos theta, and in turn you can write down it is moment of R about B is equals to, it is OB times, observe carefully, R cos theta. Your R cos theta is nothing but, so this is what is your R cos theta, or Rx you can write down the component. So, this is Rx. From equation 1, 2 and 3, you can observe carefully here adding 1 and 2, that is moment of force P about B plus moment of force Q about B, and these equations OB into Px, OB into Qx, you can take it as OB common, that is Px plus Qx, and from figure you can see that Px plus Qx is nothing but Rx. This you can write down OB into Rx. So that means this is nothing but your equation 3, moment of the resultant force, about B. So hence it is proved. The moment of the resultant force about B is the algebraic sum of moment of the component forces about P and Q. Let us refer this. So this is proved. I hope you have understood this particular concept. Thank you for watching this video.